Every time you turn on your laptop or washing machine starts working, a tiny decision made by an engineer is controlling everything. That decision is this: microprocessor or microcontroller. If you choose wrong, your project fails. If you are learning embedded systems, computer architecture, or building real-world electronics, this difference is not theory. It decides power consumption, cost, performance, and whether your device lasts hours or months on battery. Now let's simplify this. A microprocessor is like a powerful brain, but it needs a full body to function, while a microcontroller is a complete mini human with brain, memory, and senses all on one chip. So, a microcontroller is a small computer on a single chip. Inside it, you already have a CPU to think, RAM to remember temporarily, flash memory to store programs, and a built-in peripherals like timers, ADC, that is analog to data converters, and communication ports. And that's why microcontrollers are everywhere. So your smart thermostat, your smart wristwatch, and even your TV remote, they don't need massive power. They need fast response, low energy, and reliability. Now let's talk about microprocessors. A microprocessor is a pure raw computing power. It has arithmetic logic units, control units, registers, cache memory, but here's the thing: it cannot work alone. It needs external RAM, external storage, and external inputs and outputs. And that's why microprocessors live inside laptops, servers, and gaming systems. So in terms of the architecture, microprocessors use von Neumann architecture where instructions and data share the same memory path. Then for microcontrollers, in terms of its architecture, microcontrollers use Harvard architecture where there is one path for instructions and then there is another for the data. That means microcontrollers can read instructions and process data at the same time. Alright? So, in terms of their performance versus the efficiency, microprocessors win in terms of performance because it has gigahertz speeds and it has multi-core processing. Then microcontrollers win in efficiency, but then it's in kilohertz to megahertz in terms of speed. So, but it's optimized for real-time control. So, microprocessors win in performance, while microcontrollers, they win in what? Efficiency. All right. So, one run AI models, the other controls motors, sensors, and signals perfectly on time. So you can already tell that the one that can run AI models is the one that wins in performance, which is microprocessors. Here is a table where I've listed out various different applications and whether or not a microcontroller or a microprocessor or both are the best solution for that particular feature. So the first one that we have is Bluetooth. And for Bluetooth, typically that's low enough data speeds that a microcontroller is going to be using. All right. So almost all Bluetooth radios, they use a microcontroller. So microcontroller work best for such feature. All right. Then for Wi-Fi, that can also be done with microcontrollers such as the ESP32, which is very fast microcontroller. That's a Wi-Fi microcontroller, but you can also use a microprocessor if you need a really fast Wi-Fi. All right. Then you have cellular, that can be a microcontroller as well. Then you have sensors that can be a microcontroller, can be handled by a microcontroller. Obviously, it's a microcontroller. Then for GPS is another one that could be served by a microcontroller. So these are all typically things that have pretty low throughput speeds. All right. Obviously, controlling a motor or solenoid is going to be in the realm of a microcontroller. Microcontroller can handle that as well. Then for an SD camera, when you say SD, simply means a standard definition camera, can be best served with a microcontroller as well. And even 720p HD video, then a microcontroller can be your best choice as well. So it's once you get into high definition HD videos of 1080, or not just HD, but 1080p HD. All right, so 1080p HD videos, then you're going to need a microprocessor. All right. Then if you want to really have advanced display, like say that high resolution display that's in a smartphone, then you're going to most likely need a microprocessor. Or you could use STM32F469, all right, for that as well. Then we have the USB 3.0, and for that you are definitely going to need to use a microprocessor. It's just that data speeds are too fast for any microcontrollers, all right, to be able to manage real-time processing. The data speed is very fast, so a microcontroller cannot manage that real-time processing. So in that case, you're going to need a microprocessor, all right. But then a microcontroller is going to be best if you are looking towards long battery life and a small product as well. All right, you're going to need a microcontroller. All right, it's going to be the best solution for long battery life and a small product size. All right. So then if you're looking for, like we've already said, advanced data processing, it's definitely a microprocessor. It's going to be your best option since those excel at processing large amounts of data, all right, at a very high speed. So you need a microprocessor. And then finally, if you have a graphical user interface, you could use a microcontroller. But if it gets to be really advanced and really high resolution, then a microprocessor is going to be your best option. Microprocessor is going to be your best bet if you are looking towards advanced and really high resolution. All right, so these are some of the different applications, and this is how to know whether a microcontroller or a microprocessor or both are best solutions for this particular feature. Today, these two words are merging. Microcontrollers now connect directly to the cloud, while microprocessors scale infinitely on platforms like AWS. Embedded system is no longer small devices, it's the backbone of modern technology. And if you want to truly understand embedded systems, computer architecture, and real-world electronics, subscribe to Embedded Systems Diary. We don't memorize theory here. We build, we break, and then we understand most of the things we discuss here. So like this video, share this video, and drop a question if you have any question in the comment section below. Drop your question in the comment section below. And if you have any project suggestion or you want a particular topic to be discussed on this channel, please leave it in the comment section below and I will get right to it. Thank you for watching. See you in the next video, and bye.